another thing is that it'll start slightly with slightly more easier problems. So if somebody is expecting more harder problems, so that won't be there at the beginning. In the latter half of the session, problems will be slightly better. After the session, last time also in SPC, many people were asking for an optional problem set, which will be slightly more difficult, slightly harder. So we are going to do that this time. So we'll be given a problem set which will be slightly harder. Now again, two things relating to that we won't be able to share solutions for this because this is a session for discussion of solutions of other peers. So again, that'll be optional. The good thing is that all of them will be code forces problems. So you can go and look at the official editorial, which you can see for free. Many people still have a doubt over how to see the editorial of a problem. So I'll just show for a sample problem. So say for example, I go to some old problem. So you go to this is the problem interface. You go down. There'll be an option of tutorial. You click on the tutorial. You can see the problem. Now whatever problem it was, you can see the solution and the code as well, and you can look at other people's code as well. So you can look at the official editorial of problems then. Yeah, so that's the introduction part. And the most important thing is the problem solving session really makes sense if you ask doubts at all points of time. So if you don't have if you didn't understand anything, so feel free to ask doubts. Don't think that somebody is not asking, a friend is not asking, so I won't ask. So yeah, ask your doubts. We'll be completely willing to answer them. So with that said, let's get started. So I am discussing 3 problems. So we'll start with the problems. Now I'm not able to access the chat due to some reason. So yeah, I'm still not able to access. So you can read the problem here, or you can search for 1703F, and you can see the problem on your own system. So just like search code forces 1703F, you can see the problem, and you can try solving it from here. I'll give you some time. So say 4:45 or so, we'll discuss it. So yeah, you can go through the problem once. Is the problem statement visible?
Yes, Anmol.
Right. Yeah, and also yeah, please speak something. I know it's kind of awkward for you to speak something, but the session will be more interactive in that way. So, yeah. Okay. I'll mute myself. In case you have any doubt on the problem statement, you can ask. We'll discuss the problem at 46. Now I told 45. Let's go to make it 46. You don't have to code it up and submit. So I mean, you can if you want to, but primarily getting the idea is also okay. Any doubts in the problem statement? I mean, okay, there's not much to read, but yeah, any doubts in that? Okay.
I think you can start discussing Anmol problem.
Yeah. So okay. So anybody got any idea over the problem? Don't worry. Don't think that it might be wrong, so I'm not speaking. Any idea about this problem? How will you start it, or anything, or any doubt about the problem? Okay. So So we'll discuss it. The thing is that now, okay. But do you want more time to think about the problem, or shall I start discussing? Okay, I'll start discussing then. So, okay, so now I'll take something to write. Right. Now, when I see the problem says that you have to count the number of indices such that this inequality is satisfied. Now, when you see this inequality, you can see this ai less than I part repeating twice. Okay, so in place of I, say there was some other index k. So ak less than k, that part is getting repeated, twice. So, dealing with a big inequality at once might be slightly difficult. So what we'll do is we'll split this inequality into three parts. So first part will be ai less than I, second part will be I less than aj, and third part will be aj less than j. Okay, so if these three conditions are satisfied, which means this inequality is satisfied. Now, how do we really check the number of pairs satisfying all these three? So, first thing is that check the first condition and the third condition. They all can be checked in O of 1. What I mean by that is, you can, for every index, you can check that directly. They're dependent on a single index. So give you an index I, you can tell me directly whether ai is less than I or greater than I. Now our main problem lies in the second condition. How do we really get the number of pairs satisfying the second condition? So, let us build our way back from the third condition. Okay. So suppose for a given index, aj is greater than j. Okay. So what I'm saying is, suppose aj is greater than j for some index j. So what we can do is we can directly discard this index, that this will never be a part of the answer, because this inequality is directly getting violated. So this will never be a part of the answer. So suppose aj is greater than j, we can just completely ignore that index. That index will never come in any pair. So we can ignore this index. Now we are really concerned about aj is less than j. Now I'll open a whiteboard probably to write down draw something. Yeah. So now the inequality we are really concerned about is I is less than aj. Okay. So suppose this my array. Okay, this is I'm dividing the array into parts. So this is like 0, 1, 2, 3, and so on. So suppose my aj is 3. Okay. So my I can range from 0 to 2. Okay. And this is all under the assumption that the third inequality is satisfied, because if it's violated, then we're ignoring the index out here. Okay. So suppose my age is 3. I'm really considering indices from 0 to 2, or I would better use one indexing. Because the problem mentions one indexing, so we'll start our indexing from 1. Okay. So suppose aj is equal to 4, then our indices can lie from 1 to 3. Now if suppose aj equals 6, indices can lie from 1 to 6. So for a given aj, you can find the set of indices which satisfy the second property. Okay. So suppose aj is, as I give you an example, aj is 4, you're considering the indices 1 to 3. Now so these indices are eligible for being a part of the solution. Part of the solution which satisfies the inequality. Now how do we know whether a pair satisfies the inequality? It needs to satisfy this last condition, that is ai less than I. So in this set of indices which you have shortlisted, you basically need to find all indices such that ai is less than I. Okay, so again I would dry run through it. So first thing is you search for aj is less than j. Suppose aj is greater than j, you ignore it. Then for all indices I from 1 to aj, what you do is you check if ai is greater than I, ai is less than I. If ai is less than I, you can increment your whatever you'll be storing the answer in say some count variable. You increment that count variable. This is the primary idea. Now how we are going to implement this? This might look as O of n square. We can optimize it. We'll learn how to optimize it. But this is the primary idea of the solution. Any doubts in this? Any doubts in this part? This 3 steps over, coming to this point, how we're going to, optimize this thing and what is the current time complexity, we'll see it now. But yeah, any doubts still now? Okay. Yeah. So now this is the idea currently. Now, how much time would it take to really implement this? Okay. So for every j, now this would really give the answer for a single j. After you go through this would give the answer for a single j. Now we are supposed to do it for all indices j. Okay. So we are supposed to do it for all indices j from 1 to n. Right. Now you see this thing. This I can actually go till O of n square. This thing will come here. Yeah. So this this code can go O of n square. Why? You're iterating j to 1 to n, and again you're iterating I also from 1 to aj. So suppose all aj is say, so a of n is say n, you'll again go I is equal to 1 to n. A of n minus 1 is say n minus 1. You'll again go 1 to n minus 1. This code snippet is O of n square, but this will actually completely work. This logic is completely fine. We just need to optimize it in some way. Okay, now first we need to see, can O of n square work? Okay, so n is of the order of 2 into 10 power 5. Now the thing is, in every 1 second you can do roughly, 1e7 10 power 7 to 10 power 8 operations. So 2 into 10 power 5 square will become 4 into 10 power 10. So that will take a lot of time to run. So we don't have that much time. We get a TLE if you submit this thing directly. So we need to somehow optimize this. So observe that the major point is, can we really avoid this loop? This loop from I is equal to 1 to aj, we are checking ai less than I count plus plus. So now you see, say for some other j, some other j, aj is say 5. Okay. So for that j, you will be checking these things. And for say j plus 1, aj plus 1 is 4. So you'll be checking this part again. So you just observe that you are checking these 3 cells multiple times in these 2 j's, for these 2 j's. So for 1 j, suppose aj is 4, you're checking from 1 to 3, and suppose aj is 5, you're checking from 1 to 4. So you're kind of repeating things, and due to those repetitions, you're getting an O of n square solution. So we somehow need to improve it. So what my idea now is, suppose for the index, let's create a new array. Okay. What I'm saying is, suppose ai less than I for that index. Ai less than I. What I will do is, I will set bi to be 1. So if ai less than I for all I, if ai less than I, bi is 1, else bi is 0. Now what is the benefit of creating such an array B? The benefit is that, suppose I really want to get this, what I can do is, I can create a prefix sum type thing of this array B to get the answer. So suppose we populate array B and we get something like this: 1 0 1 1 0 1, and I ask you, tell me the number of indices less than index 6 which satisfy ai less than I. How will you do that? Thing is, you can just calculate the prefix sum of this array and that will be the answer. So in this case, the prefix sum is 1 plus 2 plus 1 plus 0 plus 0 1 plus 2 plus 3. Prefix sum is 3. If I ask you number of indices less than 6 which satisfies the inequality, it will be 5. The advantage of making this BI is that this step can now be done in O of 1. So what you could do here is, now you can check if, so you can actually remove this part also. How you will remove that is, if bj is equal to 0, then you can continue. What does this mean? Suppose bj is 0, which means bj, ai is greater than I at that point of time. Then only bj will be 0. So if ai is greater than I, we have already seen that if aj is greater than j, you can ignore the index. So if bj is equal to 0, you can ignore it completely. You don't even have to take care of this condition anymore. This bj part will take it. Now, for every index, suppose now you know that bj is 1. So what you will be really concerning is sum plus equals. So suppose sum is your answer, or initially we took count. You can do prefix of bj minus 1. What is this trying to do? This is saying that suppose my bj is 5. What I really want is the number of indices from 1 to 4 which satisfy the property. And we know that our prefix of I gives the number of indices from 1 to I which satisfy the property. So suppose I want bj equals 5, I want the indices from 1 to 4. So bj minus 1, will go to 4, so you'll have 1 to 4. So that is how you would really solve this problem. Now, how do you calculate this prefix? It's a very standard method. You can run a loop, say for I from 1 to n. You can do, if I is equal to 1, then you can set prefix of I is equal to bi, else prefix of I minus 1 is equal to, prefix of I minus 1 plus bi. This is how you would calculate the prefix array. Basically, what you're doing is, the prefix array of this index is prefix array of the previous index, that is from here to here, plus this number. So the prefix array is basically telling prefix sum of I will tell that sum of numbers from 1 to I. Okay, so to summarize everything again, what we really needed is that we had to check all these 3 conditions. So we have written a code something like this. So we initially made a B array, a second array. Now we basically check both these conditions using the B array. So we can write, if this condition is satisfied, then you make b equals 1, b equals 0. The motivation for is that suppose for a given index I, you want all the indices from 1 to I minus 1 which which satisfy the property. You can get it by the prefix sum of this array. So I populate the prefix sum array here, and for every index, so this will be aj. For every j, I can do prefix of aj minus 1. Okay, that is the idea of the problem. Now you can code it up once. I've given you kind of the pseudo code. Yeah, any doubts in the problem from the beginning? Any of the steps you had it out? Keep the steps out here. Yeah, any step you had it out in this. Okay. Yeah, so let us move ahead to the next problem. Problem is called edit distance. I'm able to see the chat now, or yeah, I'm still not able to see the chat. This is not a code forces problem, but what you can do is you can Google edit distance CSES. You get the problem. So something like this: edit distance CSES. You get this problem. You can see the problem for there, or else I'll show the problem out here. Okay, so I'll mute myself again. If anybody has a doubt in the question or the previous problem, you can ask. I'm here only. I'll answer it. You can take some time for this problem. Now, this problem actually is very much an application of what you did in the last session. This will test actually whether you have really understood what you have done in the last session properly. Yeah, say around 5-3 we'll discuss. Is the problem clear? So basically, you're given two strings, and you're supposed to find the number of operations to convert one string to other. Now, what are the operations? You can add a character. So suppose a movie, you can add say an S at the end, movies. You can remove a character. So suppose you remove I, so it'll become MOVI. You can replace a character. So suppose you replace VYD, so it'll become MODI. So you can do these two operations. Then someone need to convert this one word to the second word. Yeah, so that is the problem. So like in this case, you can replace the L of the first word by M, so it'll become move. Then you can add an I between V and E, so it'll become move. So there are two operations. Minimum number of operations is what you. You can take some more time, maybe around 5 we'll discuss. 5 or 5 6. Yeah, so any doubts in the problem statement? Or anybody would like to speak something for the solution? Any idea or how we can approach the problem? Okay, so I'll discuss it now. Yeah, so edit distance. Now, this problem is actually very, very heavily inspired from a problem which you did previous session. That is your longest common subsequence of, two strings. Very, very similar concept, it's just pretty much an extension of that. Okay, so now, this is a DP problem. You can see the heading also out here. It's dynamic programming. First, we need to think about a state and transition. Okay, so what state can we have? So we have two strings, S and T. Okay, and what we need to find is the edit distance of the two strings S and T. So we'll take a very similar state as we had done in least common subsequence. Sorry, longest common subsequence. So we'll have a 2D DP, a 2D array. What this would say is, what this is representing is the edit distance taking first I characters, or I would say I plus 1 characters, because I'm taking 0 indexing. So, suppose I say DP 00, taking first character of S and first character of T. First I plus 1 characters of S and first J plus 1 characters of T. Okay, so this is what my DPIJ is representing. That suppose, just take this example only. Suppose you have love and movie. So suppose in this case I write DP of say 2 and 3. Okay, so what it's saying is you take 0, 1, 2, you go to this part, and 0, 1, 2, 3. So you take this part. It's asking the edit distance of these two strings. Okay, that is what DP 2, 3 is representing in this thing. So that is the meaning of that is our state. Now how do we build up to a transition? So we somehow need to relate DPIJ with lower I's and J's. Thing is, now suppose you take this example itself. Now the last letter is already matching, so you don't have to do any operation to really convert the last letter into something else, because the last letters are already matching. So suppose I say find the edit distance of this. Since the last letters are matching, you could completely say that those letters don't even matter. Just as an example, suppose I gave you, I put like 5 A's out here, and I put those many same number of A's out here. The edit distance is still the same. Simple reason is that all these letters are same in both the things. They can safely be ignored. Okay, so if the last letter is same, then we can completely ignore the last letter, and we can consider the other part of the string. So suppose somebody asks me DP of ij, how do I relate it? And I say S of I is equal to T of j. What does this mean? So S of I is basically this. So suppose I take 2 and 3, DP of 2 and 3. So I'm basically 2 and 3 will be this. I'm basically concerning with these two strings. I'm finding the edit distance of these two strings. So S of I will be the last letter of this string, and T of j will be the last letter of the second string. So if somebody asks me the edit distance of this, and these both are equal, so this was also say V. So what I could do is I could completely ignore the last letter. Okay, I could completely ignore the last letter, and I could just check the other part. So when I'm ignoring the last letter, what is essentially happening is I'm now finding DP of, I've ignored the last letter in S. So now there are only I minus 1 indices. So initially, I was 2, so there were 3 things. Now I is 1, so there are 2 things. So dp of I minus 1. Now for the second string also same. I remove the last letter. So you have one less letter than initial. So initially there were j letters. Now there are j minus 1 letters. This is, very similar to what you have done in LCS. You are doing if s of I is equal to t as j, you are doing 1 plus dp I minus 1 j minus 1. So if the last letters are same, this is what you do. Now suppose the last letters are not the same. Okay. So in this example as such. So, if we are doing our operation on this string directly, what would happen is the e's get eliminated. Because the e's are same, we don't need to really care about the e's anymore. Now the interesting part comes when the last letters are not the same. What do we do here? So suppose I want to convert A into B, you can convert B into A also, anything. So let us see the operations. Okay, you have 3 operations. Let us consider every operation one by one. So suppose it's saying add 1 character to the string. So if I really want to add 1 character to LOV and I want to make it equal to MOVI, I would obviously add the last character of MOVI. So in this case, the last character is I. So if this was a lot more letters, say something like this, what I would add here is, the last letters are not matching. What I would do here is, I would add a letter to S, which is same as the last letter of T. What happens with this is, now the last letters of S and T are matching. So this is one way of performing an operation. Which operation is this? Adding 1 character to the string. If I'm really adding a character, I would add a character such that, the last letters match. In that case, now, we see our previous example. Now, the last letters are matching. So you could just remove the last letters. That is what we have done, If S of I is D of J, you can just remove the last letters. Now observe what has happened by this. What has happened by this is, S, let us see the length of S and T. So I added 1 letter to S and I removed that letter. So S's length remains the same. So the first index is representing S length, the second index is representing T's length. So the S length remains the same. So it's still I here. Now consider the T's length. Now this initially had a O here. Now this O is removed. And there were no additions. So what is happening out here is T's length is reducing by 1. Here at dp of I of j minus 1. That is what is happening for for addition. You can remove the last character and you're adding at first 1 character to the first string and you're removing it again. So essentially it remains same. This is for addition. Now suppose you're removing. Okay. So suppose in this case, so say this had some lot of stuff and I want to remove this letter. So what would really happen here is, I'm not making any change on T. I'm just removing a letter from S. So, and also here in addition, I do 1 plus because I've just done the 1 operation. The addition is also considered 1 operation, so I do a 1 plus out here. So in removal, what I'm doing is, I'm removing 1 character from S. So essentially what is happening is, T's length is not changing because I'm not doing any operation on T. Okay, so if I write dp ij here, 1 plus, now this 1 is coming because of the removal operation. We'll leave the first index as of it just now. So the second T's length is not changing, so it's still J. S's length is reducing by 1 because I've removed the character. So it's this. So it's I minus 1 now. So 1 plus dp of I minus 1j. This is for removal. Okay. So what is happening here? You're removing 1 letter from S. So that is reducing by 1. And you're not altering T. So it's remaining the same. So that is removal. This is one more operation which we can perform. Third operation we can perform is replacing. So in this case, say, our initial strings were this. So suppose you had say an P here. What replacing is saying is you'll replace the last letter with something. Now if I'm replacing, I will obviously replace it with the last letter of the second string. So that these two, this I and this I gets removed. So if I really want to replace, I would replace it with the last letter of the the other string, so that these both both the characters can be removed. So after replacing, what is happening? After replacing, the characters of both these things are becoming equal. So it's exactly same as this. So it's becoming I minus 1, j minus 1. Basically, you can remove this letter from here. You can remove this letter from here. You can remove a letter from both the strings, because they both are equal now, because you replaced one different letter with the same letter. So this will be 1 plus. Now again the 1 is coming because of the removal operation. This is for replacing. Okay, so these are the three things which you can perform. Now the idea is to get the minimum number of operations. So you really want the minimum in all these three cases. So this 1 plus is common. So ultimately what your thing would become is, if S of I not equal T of j, dp of ij is equal to 1 plus minimum of all these things. So dp ij minus 1, this will come for addition. dp I minus 1 j minus 1, I minus 1 j, this is for removal. And dp I minus 1 j minus 1. This is for replacing these three minimums. And if else if S of I is T of j, then it's just dp of ij is equal to dp of I minus 1 j minus 1. Basically you can just remove the last letter and without performing an operation, because they're the same. Now this is essentially the the transition of that thing. Now we need to define some base cases. You can do that. So basically the base case will come when I is equal to 0 and j is equal to 0. So you could manually see whether if I equals 0, whether this is matching with the character or no, and you could define the base cases. So yeah, basically the base cases will come whenever these things go out of bounds. So here I minus 1 is there. So at I equals 0, they'll go out of bounds. So at that point of time, you have to manually define the case based on the input. Similarly for j. So this is basically the state and transition for this. And if we can probably dry run this on this. So what is happening is, here E is getting removed. Then again you do all the three operations out here. You check with these three operations. It turns out that you have to do some it'll become slightly lengthier. So probably you can leave it to the system to do it. If it was probably a slightly smaller example, we could dry run it. Yeah. So yeah, so that is edit distance. Very similar to what you did yesterday, that is LCS. So LCS also you saw these terms, and there is not this was a maximum there, and there was no 1 plus. Very similar ideas. So, yeah. That is edit distance. Any doubts in this? Any doubts in any of the things I've written till now? All these three possibilities. No doubts? Okay. So we can see the next problem. This is the last problem from my side. Okay, this is the problem. I'll probably put it on full screen so that it's visible. Okay, I'll explain the problem first. Problem might not be clear. Multisets and all, people might not be that familiar. So find the number of multisets containing numbers integers from 1 to r with sum up to n. What this basically means in simple terms is that you have a number n. Okay, suppose say n is equal to 4. I'll probably just leave it out here, right down. Yeah. So suppose n is equal to say some value, say 4, and r is equal to 2, or I would take some bigger number, n is equal to 100, r is equal to 5. Then say what the problem is asking you is, how many ways can you write 100 as sum of numbers from 1 to r you can take any number of times. What this means is, you can write 100 as 10 plus 10 plus and so on till 10. I'll take this slightly smaller so I can write it manually. Suppose I take 50, so you can write it as this. You can also write it as 10 plus 10 plus 10 plus 10 plus 9 plus 1 or 8 plus 2. And you can replace maybe this 10 by say 7 plus 3. You can write it in many ways. And so you are basically asked to get the number of ways you can write n using the first r natural numbers. And you can use any number of times. But you need to use only the numbers from 1 to r. So you cannot use something like, you can't be like 20 plus 20 plus 10. This is not allowed because r is 10, so you cannot use any number greater than r. Another thing is that order does not matter. So as in this case, so suppose you take n is equal to 4 and r is equal to 2. So 4 is equal to, suppose I take this case, this is same as this. Above both are same. Okay, so the order does not matter, just the numbers in the summation matter. So for every given number n, you're asked, 1 to, you can use integers from 1 to r, you can use any integer any number of times. Order does not matter, how many ways can you do it? So for example, I've given for 4, you can see the example. I'll give you some more time. So 22 we can discuss at 27 or 28. Yeah, I'll mute myself. Any doubts in the previous questions or in the problem statement, you can ask. Yeah. So guess we can start discussing now. Yeah. So any doubts in the problem statement, or anybody has any idea of solving it? Okay. So let us discuss the problem. Okay. So what are we going to do here? That's the reason I've given the constraints out here. So that it might give you an idea of what type of complexity you expect. We know around 10 power 7 operations can be performed. So a solution with say nr o of nr time and o of nr space also would work good in the constraints given. Okay, so we are looking for an o of nr solution. So in DP constraints play a major part. You know as a hint for you to think of the state and transition. So suppose say n was huge. Say in this case n is 25. So you can't go for an O of n square algorithm. You cannot use O of n square space. Your deep your state should not have an n thing in it. So seeing the constraints, you can keep an idea of how the state will be and what time complexity do you expect. In this case, as I told you, NR works decently well. So that is what is expected out of the problem. Okay, so let us fix our state to be dp of ij. Okay, where I is going from, so where I is going from 1 to n, and j is going from 1 to r. Okay, so I'm using basically n or space. Now 10 power 7 units of space. If you globally declare an array, you can use that much amount of space. It's fine. If you're declaring locally, so your thing will be of the order of 1e5. So you can use arrays of size 1e5 within your function, and outside the function you can use an array of size 1e7. I hope I'm unmuted. Yeah. Okay. So how do we really build towards this? Now, what is DPIJ storing? So DPIJ is storing the number of ways to write I, okay, as a sum of first first j natural number. Okay, when I say sum of as a sum of first j natural numbers, sum of its first j natural numbers is fixed, so j into j plus 1 by 2. But what I mean is that you can take any number in the range 1 to j. You can take any number of times. Okay, that is what I mean by saying as a sum of this range. And you need to write the number I. So just as an example, dp of 4 2, dp of 4 2 is 3. Okay, because if I take the numbers 1 and 2 to write 4, I have 3 ways. So these are the ways. How do we build up to the recursion now, to the transition now? Now the point is, this idea is again very similar to abstract. So so the thing is, we need to somehow relate this to lower j's and lower i's. So here one is the numbers from 1 to j are considered. Okay, so in this case we are considering numbers from 1 to j. Now how can I be created? I can be created when I say I mean this I. So I can be created by either using j or not using j. Okay, so suppose I use j. So suppose j is used. What is dpij? Dpij is basically, so I, when j is used, I is basically j plus I minus j. So we know that j is used. Okay, so Now we are really concerned about this dp of I minus j, and we can still use the first j natural numbers. I'll repeat this again. So what I'm saying is, suppose j is used. So when I'm saying dpij, I'm basically considering numbers from 1 to j. So suppose j is used. So now we are basically worried about the number of ways to write this I minus j using still numbers from 1 to j, because j can be used multiple times. So I'm worried about writing numbers from I minus j, number of ways to write I minus j, because I've already taken out j, so the remaining part is I minus j. Okay, and suppose I don't use j. Suppose I don't use j. What happens? So dpij. Now the thing is, I'm still writing I only, but I'm writing as a sum of first j minus one natural number, because I'm not using j at all. Okay, so these are the two cases. First case is, suppose I'm using j. Suppose I'm using j. So now basically I've used j already. So the remaining part is I minus j. Now I need to write I minus j as a sum of the first j natural numbers. So since it's a you can use one number multiple times. You can see one has been used multiple times out here. So you can use j again. So you need to write this as sum of first j natural numbers. That is what is shown by this part. And suppose I don't use j, I still have to write I, but since I'm not using j, I have to write it as a sum of first j minus one natural number. Okay, so these two can be the ways. Now we want the total number of ways, so we'll just add these both. Right, dp of I minus j of j plus dp of I j minus. Now you have to be slightly careful about index going out of bounds. So you have, whenever you're using this, you have to just put a condition of I greater than equal to j. Okay, what this physically means is that suppose I is equal to, suppose I give you n is equal to 4, r is equal to 6. So you're never actually going to use 5, 6 at all. Okay, because you're not allowed to use negative numbers. So if you use a 6, you have to get something negative. So what I'm saying is 6 plus something is equal to 4 means that something has to be negative, and we're not allowed to use negative numbers. So you can just discard 6 and 5 out here, and you can directly use 4. So yeah, you just have to take care of those things. You have to put something like, if I greater than j, then you put this, and if j greater than 1, you have to put this. And again, the base case, that is for j equals 0. So j equals 0 means you're using no number, so the number of ways is 0. So just by using 0, you can't create any numbers. You can't create any number. So any I. So you can add 0 100 times, it'll still be 0. So you cannot create any I. So the base case would be dpi0 is 0. So yeah, that is kind of the recurrence for this, and the base case also. So that is this problem. Any doubts in the problem? Okay. So the thing is, you take two cases, j is used or j is not used. If j is used, j is no more there. So the sum you're finding is a 5 minus j, and you can use j again and again. So you're not restricting your sample space. It's still 1 to j. You don't use j, or suppose you don't use j, the sum is being the same. You're not changing anything in the sum, but you're restricting your sample space. It's now 1 to j minus 1. So this is the thing, and you have to take the sum to get the total number of this. Any doubts? Okay, so now from now on, I'll hand over the mic to Shashank. So Shashank will be discussing 2 more problems, and then we'll have the doubt session in case people have doubts. Right, so we'll be sharing the slides. You can go through the slides, and the links are also there, so you can see the problems. Yeah, thank you.
Hello, is my voice clear?
Yeah, it's clear, Shashank.
Yeah, fine. If you stop sharing, I'll start.
Yeah, just a minute.
Cool. Okay. Is the screen visible? Like,
Yeah, it's visible.
cool. Okay, first question is first problem we'll discuss code forces 1, 2, 4, 5, 6. You can Google like 1, 2, 4, 5, 6 code forces as Anmol showed before. Like I'll keep the problem statement here. Yeah. First line is not important, so just I'll keep like huh. We can start discussing it around 5:42 or 5:43 maybe. If you have any doubts regarding the problem statement, you can ask. I'll try. I'll just explain the problem statement. If you have any doubts, like before, you can ask. Like if you have any ideas, also you can discuss. So the problem is, like you'll get a string which is processed by the machine, and you have to tell like how many strings like that the girl have inputted, but the output was this string s. So like and the statement is if there is a w in the string she gave as input, then it will output two u's, and if there is an m, then it will output two n's. So it must be clear that there won't be any W and N and M in the final output. So if our input has any M or W, then it must be invalid. So can you think of the state right now? Like you must have got some idea, right? You can discuss. It would be more interactive. Okay, then like I'll go through. I'll discuss. So our state DP of I denotes the number of strings that the machine would have turned the first message, like the into message first I characters of string s. So like uh, our our input is this, right? So a DP of I denotes like say DP of 5 denotes how many inputs would have been possible to output this string, like O, U, U, and OK. So that will be our state, and let's just discuss the sample case. So this is dp of 1, dp of 2, dp of 3, and so on. We'll just process it like so. First dp of 1 will be one string o, like, and then dp of 2 will also be one, as like you can't turn like ou can't be changed into some other the final output, like. So for, and then OUU, or it can be also uh, OW. One second, and just uh, now you here you have two possibilities, because the initial input might be OUU, or if it is OW, it will turn that into OUU. So that is you'll get two strings here. That is indirectly you are adding a W to the first case, and then a W and then a U to the second case. I'll just take the next character. So now that you have O, and then one second. And you have, oh sorry, now we will add like to the both strings that were possible. So here also it will be 2, and here OU and then K and OU, oh sorry OW, okay, and then here OU, okay. Like as this all were not U and N, so we can just proceed like without changing the values. I'll just show the final string. I guess it is taking time to type. So here there is no change. Here there is no change, as we are just adding the characters which are not either U or N. So we should observe here carefully. Like in this case, we are adding N. That is fine. And then when we have one more N, we can uh, we can add N to this, or 2N. Like here the 2N's in the initial string, it might be either M, or it can be either 2N's also. So that is one more case from this one, and other two will come when from the second one. So in second also you can add N, or like these are all the possible strings that were given as input. So it can be either 2 n's or it can be 1m. So can you notice the change, like when it is changing and how it's changing? Okay, I'll discuss. Yes. So first, DP of height. So someone is speaking. If they want to discuss it.
I have a doubt.
Yeah, sure.
Yeah. Uh, can we just count the number of instances where you have two U's or two N's
Huh.
and raise it to the power 2 and add
Hmm.
1 to the last? I mean, like, in example, in this case, you have two U's and two N's in the string.
Huh.
So it's like for each of that, you have two possibilities. So number of times, like the number of instances in which this occurs, let's say it happens in x times, so I can put it as 2x, and then for the original string plus 1, can I do so like that?
Interesting idea.
I mean, like one single pass through the string, wherever I and I plus 1 are equal to u or equal to n, like a counter incrementing it by 1, and then finally it's like 2 to the power count plus 1 for the original string as such. Can I do something
I
like
guess
that?
that will work actually. Like every time we see the occurrence of 2n's, then
2n's or
the
2
answer gets
u's?
multiplied by 2.
Mm. Even in this
Mm.
case, it's like something like that, right? Whenever you find 2u, I mean, like initially you'll have 1.
Yeah.
Whenever you have 2u's or 2n's, you're incrementing it by 2.
Mhm. So let's just say, like, if you have one more n here, then
Uh,
the answer work?
okay, in this case, my count would be 3.
But
For first 2u's, I will have counter 1. And then for the 3 means I will have like counter incremented by 2 times. First 2
let's
n's and
just
then
see the case here. Like till then it remains the same, and now we have a n and same, like, is it?
in means it should go to 4.
Yeah.
And then
One
another
second.
n means it could be like either n or
Okay.
nm
Just
or
1 second. Sorry. Let's just don't disturb this, and we can keep a
okay.
n at the end. So, like, we have come till here. So, like, can you explain what happens next?
In the final one, it would be like for 2u's, I will have 1 count. And then for 3 n's means first 2 n's I will have 1 count, and the last 2 n's I will have another count. So I will have 3 in count. I will have 3, 2 cube plus 1, 8 plus 1, 9.
Uh, 1 second. Like, okay, we'll add n to this. Like, it can be that one case, and then we can keep it as nm, right? Like here in the
Yeah.
first one.
Mm,
Yeah. So
yeah.
2 strings we got. And then we can keep an n at the end, and yeah, that's the only case here with
Mn,
this string.
nm, in. Only 3 cases will be there.
Huh.
Okay, and in this case, yeah, my method will fail.
Yeah. Like when they're consecutive, then it would fail, I guess. But the
Mm.
idea is nice. Like if they are apart, then the solution will be fine, I guess. So
Mm.
yeah, that was
Thank you.
cool. Yeah. So now we'll discuss this transition. Here the transition is, oh, sorry, 1 second. So I'll just write it up here. So it is equal to dp of I minus 1 if uh, if it is any other character, like any other character than U and N. Now, 1 second. And when the value and the previous value are both either equal to U or either equal to N, then the state then the transition will be dp of I minus 1 plus dp of I minus 2, because as we have seen, here we have seen, right, like we either add to the, like here when there is a occurrence of double n, we either add n to these two strings or we can add directly m to the previous one. So it is the transition comes like this. It is equal to dp of I minus 1 plus dp of I minus 2 if s of I equals to s of I equals to u, or s of I equals to n. And if at any point you if any point you see either m or w, then the answer will be 0, because after processing the string can't contain either m or w. So you can view the code later, I guess. Like we have only few minutes left, so if you have any doubts you can ask, or else we'll move to the next problem. Okay, we'll move to the next problem. We will not discuss vacations, no, like it was already discussed in first session, I guess. So that I don't know, that's why I thought of doing it now. Next problem is 1741E. You can Google it and see. I'll also show it on my screen now. There is like sample test case is almost explained in the statement, so I'll just show this. We can start discussing at 6 maybe. I'll just go through the problem statement. So if you have any doubts before, you can ask me. So you'll take a sequence, and then before transforming over the network, what you'll do is you split the given sequence into parts. Here they have did it into 3 parts, like 1, 2, 3, 1, and then 2, 3. What you'll do is before transmitting, what you'll do is like you'll keep the length of the sequence either to the left of it or to the right of it. I mean the length of the subsegment, length of segment. So here, what they in like there are multiple ways. Like you can keep either to the left or to the right at every point. So first in the first case, like they have uh, kept the length of the first segment to the left of the segment, and in the second also they did keep it to the left, and then at the last they kept it to the right. So there will be multiple possible ways, and at last, but now the input is not the string you have before processing it. They give you the string which is like after sent over the network, and then you should tell them if it's possible to have such a sequence before transforming. You should output yes if it's possible. You should output no if it's not. So if you have any doubts regarding the statement, we can discuss. Maybe you can just view the sample cases. So here, I'll just zoom it out. So in this case, one can be the length of the segment to the left, and two, wait 1 second. Yeah, 2 can be the length of the segment to the right of it till 1, and then 3 can be the length of the segment to the right of it. So it's possible, yes. And in this case, 12. So 1 second. 1 can be the length of segment to the left, that is 12, and then 2 can be the length of the segment to the right. So it is also possible. And in the third case, 1 second. 5 can just be the length of the segment to the right, so it is also possible. And here in the fourth case, 4 cannot be length of the sequence to the right or left, and 8 also cannot be the length of sequence to the left or right. Same is the case with 6, and same is the case with 2. So in this case, it's not possible to have a previous A which is transformed. And in the fifth case, it is possible, like 1 can be just the length of segment to the left, which is 3. And in the last but one case, yeah, answer is yes. So we'll see. 6 can, let's see, 4 can be the length. Yeah, 4 can be just the length of the segment to the right, and then here also 4 can be the length of the segment to the right. And in the last case, just one element doesn't like it can't be B. So answer is no. So maybe we can just discuss state and transition. Yeah, the state is dp of I if we will equate it to 1 if we could send b of 1 to I, like till ith characters over the network. If it is possible, then we will equate it to 1, or else we will equate it to 0. Now you can discuss if you have any ideas about transition. I'll give you 2 minutes, maybe. Like this is some difficult problem compared to previous, so you can just think about it. Is the statement clear? Like, if you have any doubts, you can ask. So, like, you'd have got an idea that the only thing you have to check is if it can be the length of some segment to the right or left, or else then you can just move on to the next. That must be basic idea. So you can try thinking about the transition now. I'll discuss the solution in 2 minutes. Meanwhile, if you have any ideas, you can tell them. Okay, I'll discuss the transition. So, like, we'll have to check if P of I, like the ith index, value at ith index in the array given as input. So, if it can be the length of the segment either to the left or to the right. So we'll just like I'll just discuss it. So if B of I is length of the segment to the left of it, so then if it has to if it has to be the end of the segment, then then when it is possible, like only when dp of I minus b of I minus 1, which is okay, I'll just discuss with this case, I guess. Sorry, 1 second. Ooh, give me a minute. I'll just discuss. I'll just discuss this case one. So now here one can be the length to the segment which is right of it, and so we can equate we can just process dp of this as like this. So if it can be the length of the segment which is to the right of it, then you can take the base case as dp of 0, which is equal to 1, and then why is this? So what I'm checking is if it is possible to be the length of the segment which is to the left of it, then if we move like b of I steps to the left, and then it must be possible that the segment at that position, the value at that position should be the length of the segment which is to the left of it. Then only it's possible. And if it is the length of the segment which is to the right of it, then we'll have to check. It is only possible if, wait, this is dp of I minus 1. Sorry, it's a typo. So it must be the case that dp of I minus 1 is the length of the segment which is to the left of it, and dp of I plus b of I, then we will equate it to the 1. So just read these two statements. If b of I is length of the segment which is to the left of it, and it is only possible when dp of I minus b of I minus 1 equals to 1. And then we can, if it is equal to 1, then we can equate dp of I equals to 1. And if b of I is length of the segment to the right of it, then it is possible only when dp of I minus 1 equals to 1. And then we can equate dp of I plus b of I to 1. Any doubts? Like, I guess it might be confusing. Shall I just go through the code one? So this is the thing. If it is if we can transform till the value just before it, then we can check if it can be the length which is of the segment which is right to it. And yeah, that is this case. Like if we can transform just before the value I, like dp of I minus 1 equals to 1, and I plus b of I less than n, less than or equal to n, then we can equate dp of I plus b of I equals to 1, because a of I can be, here b of I can be the length of the segment which is to the right of it. So we can the transformed values, that is b, it is possible till I plus bi. And yeah, the second case is we are checking if it can be the length of the segment which is to the left of it. That is, if it has to be that, then dp of I minus b of I minus 1 should be equal to 1. So then we can equate dp of I to 1. This is if you have any doubts, you can ask. The final answer is dp of 1. If it is 1, then we can then such b exists, like after processing from a. And if dp of n is 0, then answer is no. Any doubts you can ask?
Well, I have a doubt.
Yeah, cool. Go on.
Here, I plus b of I should be equal to n or less than equal to n. Because let's say I have I mean the fourth character from the last, but the value is something like 8 or something like that. In that case, it would satisfy it, but the length will be length of the length mentioned in that value will be larger, right?
Can you just discuss, like, can you tell one case? Like, I did not get it.
Let's say the last 4 characters are 8, 4 to 1.
8, 4 to 1. Okay.
In that case, when you are checking for the 8th one, that index plus index value plus b of I would be no.
Here 8 can't be length of segment which is to the right of it, right? So it's not possible.
Okay. Let me say it as 3 then. Sorry, 2 then.
Which instead of 8, you will keep it as 2.
Yeah, 2.
Okay,
2, cool. 4 to 1, something like that. In that case, I plus b of I would be like less than n. But
Yeah.
2 is not the length that is to the right of the one, right?
Yeah, in this case, actually, it is not possible to process till the end. Like in this case, the answer must be no, right? So, like 2 can be the length of the segment which is to the right of it till 2. Like, and if we come to 4, it can't be length of either to the left or to the right. And if we say 2, this 2, then it can be length of the segment which is to the left. And 1 can't be length of either the segment. Like 1 can be length till here, right?
Okay.
So yeah, dp of 1 will remain 0 even after processing, because there don't exist a such that like after transforming it becomes like this. Maybe like if you can come up with one set of values where solution exists.
Okay, I'll actually think about it and then.
Yeah, you can just ask your doubt. Like I didn't get the doubt.
Like, well, my main point is like when you're checking for the right side, shouldn't it? I mean, like it should be like exactly equal to n, right? When I'm checking for to the right, when I'm checking from my current index to the
I
end
got
of
it.
the array, it should be like properly checking for the length of the array, right? It shouldn't be like less than or equal to, right?
What we are doing is like we are just our state is if it is possible till ith position, right? So we are just doing we'll increment it by a of I. So with this as the length of the segment to the right, it can go till 4 2. Like that is the state.
Okay.
So we'll
Okay,
just get all the possibilities of like till when it's possible for, by going through all the values, and if at the end if dp of n is equals to becomes 1 at any point, then that means there exists such an a which transforms over the network and becomes v.
Okay, but I will analyze it further and then
Sure.
Thank you.
Yeah, if you have like you can ask in the group or you can message in WhatsApp for me.
Okay, bro. Thank you.
Cool. Any other doubts? Like you can ask doubts if you have any problem set 1 on problem set 2 also. If you have any doubts like in the problems discussed till now, or any problem in the problem set, you can ask, like we'll discuss, or else I guess we can leave.
Okay, thank you guys for being in this session. Yeah, if you have any further doubts, you can always WhatsApp any of us or put it in the group. Thank you. We can wrap up this session.